A turret punch can put a hole in sheet metal in a fraction of a second, and it can do something a fiber laser physically cannot do at all: change the shape of the sheet. That single fact decides which machine wins a job far more often than cutting speed does. By the end of this, you will know exactly which parts belong on which machine. Start with how each one makes a hole. A punch is pure mechanical shear. The tool pushes into the sheet, the metal cracks between punch and die, and a slug drops out. There is no heat, no melting, and no gas. The whole event is over in milliseconds. A laser makes a hole by melting a path and blowing the melt out with assist gas. It never touches the sheet, so it does not care what the outline looks like. A circle, a logo, a curve nobody has tooling for. Same cost to the machine either way. That difference sets the first rule. Punching is fast per hit, but every distinct feature needs a tool. Laser is tool-free, but pays cutting time per millimeter of edge. So the punch wins when one tool is reused hundreds of times, and the laser wins when almost every edge is different. Now, the part that comparison charts leave out. Punch tooling can form Louvres, dimples, countersinks, embossed ribs, card guides, knockouts, and threaded extrusions that let you tap a thin panel without a nut. Those are all done in the same cycle as the holes in one setup on the flat sheet. A laser cuts an opening and nothing more. Punching has hard limits, though. Tonnage caps thickness, so turret presses live in thin to medium sheet, not plate. The rule of thumb on mild steel is that a hole should be at least as wide as the sheet is thick. Go smaller and you are punching a slug taller than it is wide, which snaps, punches, and wears dies fast. Clearance is the other number that decides edge quality. The gap between punch and die is a percentage of the material thickness, and it goes up as the material gets thicker and harder. Too tight and the punch loads up and wears. Too loose and you get a rolled edge and a big burr. Wrong clearance is behind most bad punched edges people blame on the machine. And a punch cannot make a smooth freeform outline in one shot. It nibbles, overlapping hits along the path, which leaves a scalloped edge and takes many hits to travel a short distance. That is exactly where the laser walks away from it. And it is why long curve profiles are laser work even in a shop that owns both machines. Then there is the secondary work. Punching leaves a burr on the die side of every hole, so deburring is usually planned in. A fiber laser edge on thin sheet is square and near burr free, but on mild steel cut with oxygen, it carries an oxide skin that paint and weld prep will not tolerate. Neither machine hands you a finished part for free. So cost it properly. Machine rate per hour plus consumables divided by real parts per hour, and then add the tooling. For the punch, that tooling is a genuine cost with a lead time and a regrind schedule. For the laser, it is nozzles, lenses, and assist gas. Run the same part through both estimates, and the crossover is obvious rather than a matter of opinion. The short version: high volume thin sheet with repeating holes and formed features goes to the punch. Thick material, one-off parts, and anything with complex profiles goes to the laser, which is exactly why the busiest shops run both, and why punch laser combination machines exist at all. Next episode, how a panel bender folds a box in seconds and where it beats a press brake.